Hi, so in this video we'll be discussing a problem to design power transmission system, specifically in chain drives, okay? So, as you can read in the problem, so you have a single strand, number 25 roller chains. This is your small sprocket. Say it has 14 teeth and so forth. Is this your teeth? And your small sprocket has a speed of 700 revolutions per minute. So this is your chain pitch, okay? It is 3/4 of an inch or 0.75. So you want to determine the number of strands. This is your number of strands, right? If you want to transmit a horsepower of 85 HP, okay? So when designing chain drives, we will be using the design equation for link plate fatigue and roller bushing impact, okay? So for the rated power, you can see this on page 466 of the book Design of Machine Elements, 4th edition by Virgil Fires, okay? First equation, we have HP equal to KT, the number of teeth of the small sprocket raised to 1.08, and then your sprocket speed raised to 0.9, pitch raised to 3 minus 0.07 of your pitch, and this is your link plate fatigue equation. Okay, KT value is 0.004 for all other roller chains, okay? It will, however, differ if you have a roller chain number of 41. So you will be having a value of 0.00224 RC equals 41. Now for the other equation, we have roller bushing impact. The rated power is in KT multiplied by your 100 multiplied by your teeth of the smaller sprocket over the velocity of the speed of the smaller sprocket raised to 1.5 times pitch raised to 0.8. And this is your roller bushing impact. Equation. So, the KT value will differ, okay? KT value will be 17 if between 40 to 240, okay? KT value will be 3.4 if the roller chain is 41, okay? What else? Will be 29 if roller chain value is 25 and 35, okay? So again, the units here, this is simply your teeth, and must be in RPM, and the pitch must be in inches, okay? Okay. So using, let's say this is our equation 1. This is our equation 1, for example. And this is our equation 2. So using equation 1, okay, the HP, or rated power per strand, is simply so using our link plate fatigue equation, the HP per strand is simply 10.77 HP per strand. Okay. So using equation 2, using our roller bushing impact, since this is roller chain number 25, we'll be using KT value of 29. Okay, so HP per strand is 65.16 HP per strand. Okay, so if it is asking for the number of strands on an explanation by Fires, we want to use the lower HP, okay, for us to maximize the number of strands. So if per strand you are holding, okay, if per strand it can hold a power of 10.77 HP, to get to 85 HP you need at least around probably 7 or 8. So let's find out. So you want the number of strands. So it's simply the designed HP per the rated HP per strand of the roller chains. So it is simply 85 HP, 10.77 HP per strand. Answer here is, so you have 7.892. Since the strand cannot be in decimal, they're always in whole numbers. It is simply 8 strands, okay? So how about for using our equation 2? We have 85 HP, 65.16 HP per strand. It is simply 1.304 strand, approximately 2 strands, because we can't have decimal on the strands again. Okay, so what does FIRES mean by use the lower HP? So you have to use the lower HP rating, or the lower rated power of the strand, so you would have more strands. Okay, so for example, we have, say on our next problem, if this is, let's change our RPM to 1800. Okay, so at equation 1, HP per strand is what? Let's try using that equation. It's still 0.004 since we're using roller chain number 25. Teeth is still 14. And the speed is now adjusted to 1800. So now the speed has been adjusted to, sorry, the rated power is now been adjusted to 25.2 HP per strand. Okay, now if you use the roller bushing impact equation, HP per strand is now, we are still using number 29 since the roller number chain hasn't been changed. Okay, so now the rated power per strand has been reduced to 15.802 HP per strands. Okay, now again we'll be using, if we want to design our problem, let's just ignore it here. We want to use the lower rated power so that we could get more strands. Okay, so number of strands again is designed over rated HP per strand. Okay, it's still gonna be 85 HP over 25.2 HP per strand, and the other is 85 HP over 15.802 HP per strand. So it approximately will have 4 strands here, and you would have around 6 strands here. So to compensate for the 85 horsepower, you need at least 6 strands. Now, the problem will be easier if it will state determine the maximum. If it's the maximum, we always go by the design, which is the lower HP or the lower rated power to get the maximum strands. But if the problem states that you want to determine the minimum number of strands, then we go by the higher rated HP, so that we could get the minimum number of strands. Okay, so I hope this video helps you a lot in designing power transmission system in roller chain drives. I hope to see you in the next one. Please like and subscribe. Thank you.